Hello. Hello.
Hello.
Hi, good evening.
Good evening. Yeah. So I
Hi,
think
Jordan.
hi Elvis and is an A. Yeah. We have double A and A. Yeah. Hi Iram and Norman. How are you guys doing?
Hi.
So hope you guys had a great week as we end this week in style today. So yeah. Hope Ilam, you were able to resolve some of the errors that you had in the last part. Hello, Ilam. Were you able to solve your error?
Actually, my laptop is hang. I got a black screen error.
Oh,
So because
okay.
of that, I cannot work further.
Okay. Okay then.
And I'll put one on that command means lies between 0.4 to 0.9, but it not work.
Okay. Try changing all the smart contracts that you have, so that
Okay.
they have, you see, like mine, all of them are pragma 0.5. All of them are pragma 0.5. So make sure all of them are pragma 0.5. Even the migration one. Make sure if it doesn't have if it covers the range, make sure that it covers the range that you are using. So make sure all of them are pragma 0.5. Yeah.
Actually, it shows me pragma solidity for 5.14. But when I'll put that, then I'll get a error. And if I'll put 0.5 point, then it shows me that turfal, upgrade your turfal.
Okay. Try to update it, and then make sure all the smart contract are using 0.5. All of them are using 0 greater the way that I have written, and you should be good. Yeah, because it's an issue with the pragma, the solidity compiler version. So make sure that you either you upgrade your truffle, or you make sure that all your solidity or all your smart contract have pragma 0.5. Yeah. So yeah, it should work.
Okay.
Yeah, it should work. Yeah. Then is there any other person who had an issue? Or alternatively, what you can do, let me show you. If you also encounter that the same error, you should just a minute, I'm just going to look at the the other alternative is to set the compiler version here. So I'm just trying to look at how you're going to set it so that so you should be able to add, I'm looking for the you should like the truffle version that you have on your machine, you should be able to set the version directly here. Here. So I'm looking for the command or the line of code that you need to add there. The way it's already written here, so the only thing that you need to add is to just to add a version. I think it's the version. Let me just get the right one. Yeah, it should be version. Should be version without it should be the version. So version 0.14 for you. 0.5.14. Yeah, it should be like that. Yeah, it should be like that. Yeah. So you can make truffle config use that version of truffle there like that. Yeah, so you should also be good to go. Yeah, if it doesn't work, hello, Idam.
Hi.
Yeah, so you should be able to set your truffle like this. If it doesn't work, the last alternative is to upgrade your truffle. Yeah, the last option is to upgrade your truffle. So we should be good to do this. And then also make sure all your smart contracts are using 0. The version you have installed, the version truffle is telling you to use. Make sure that all your smart contracts are using the same, even for the migration. Make sure that the migration is also using the same file. Yeah, so you should be good now. Yeah. So for me, I won't be.
Okay, I'll just try that.
Yeah, so for me, since mine is working, I'll just use that one. Yeah. So for guys who are joining us today, that is Isla, yeah. Know whether I'm pronouncing it right. What we are doing, we are building a yield farming application in Solidity, a smart contract that is yield farming. So far we had we had created as a Celo dollar and a Uniswap crone. That is these are ERC20 token. And yeah, so what we'll be doing is swapping between these two tokens. So swapping with from Uniswap to Celo and staking them. Not swapping, but staking. Will be staking and unstaking the coins. So once you stake the Celo, you get rewarded with Uniswap and vice versa. Yeah, and you can also be able to unstake such. So this one is just a simple. It's just a simple tutorial, and it's for learning purposes. So I wouldn't advise you to use this one for deploying something. You really need to do more than this. You need to add more functionality to you need a factory. Let me show you the Ubisoft website, which you can also be able to like so that you can be able to so this is the Ubisoft interface, like the entire application Ubisoft interface. It's open source. You can actually clone it and try it out. So this is the front end part. This is the front end part. So this is the front end. It has a lot of stuff. So I was just trying to study this application so that I can see if it's something that I can be able to use. Yeah. So these are a lot of things which are there. Yeah. So like token warning and stuff like that, and wallet model, connectors and stuff like that, and data. So yeah, so there is a lot of things that you can be able to do once you are able to do that. So what I want to show you now is browser had an issue. I want to show you the link where you can be able to get to see more on Ubisoft, like the entire Ubisoft smart contract. Sorry. Like the entire Ubisoft smart contract and its structure. If you are willing to go an extra mile and create your own swap, all your own debts, yeah. So yeah.
Thank you. I'm following.
Okay. Just a few minutes. So this is the Ubisoft website. It's taking a while to load. So let me share the link for Ubisoft website. This one. So this is the Ubisoft website. It just does the same thing. It works the same as Uniswap. So if you have Celo and you want to swap the CUSD, so you just have to swap and then you connect it with your, let me just launch the app. And then here we have the Ubisoft smart contracts. The smart contract, these are the documents. These are the Ubisoft document. They have what we call Ubisoft SDK. They have a SDK that can connect you to the Ubisoft. So if you want to interact with the Ubisoft, and then they have the Ubisoft website. So this is the Ubisoft site with some few details. the Ubisoft. So this is the Ubisoft. So you can see they forked it from sushi swap, and they created their own Ubisoft now. And then if you dive deeper into the contract itself, it has interfaces, it has libraries, it has the Uniswap version 2 ERC20 Sol, and the factory and the pair and the router. So what we have right now on our side, closed my so what we have right now on our code, we have the ERC20, the one that we want to swap, and then we don't have the pair, but we have the factory. We have kind of the factory which we are calling the YieldFarm, which so the factory has a lot of that's the fee to setup. It has a lot of things. So if you want to make it commercialize it and do a lot, it's quite interesting what you can be able to do. There is the create pair, there is the set fee. If you want to set fee for people to transact, you're creating a platform and you also want to gain some fee out of it. So there is the factory, and then we have the pairs, .sol pairs, which has minimum the amount of tokens that you can be able to exchange. So from factory token, so they have been able to do the same thing we are doing, but now on a more complex way. So you can see the reserve. It contains the liquidity pools and such. So these are lot, and then there is the mint fee if the tokens are being minted, new tokens and update and stuff like that. So, and then there is also ban. So this is what I was telling you guys, to add function ban for banning token. So should be called from a contract which performs important safe checks, and and then now there is the function itself for swapping. So basically it has the same thing that we were doing. It requiring the amount, it has to be greater than 0. And then it has to check a lot of things there. Then the balance of 1 and balance 2, token 1 and token 0 and token 1, and then the balance is updated and stuff and more. So so that is the Ubisoft. So this is the Uniswap SDK as part of their documentation. So the SDK, the Ubisoft SDK basically looks the same way as the one for Ubisoft. It's just the name that has changed. So so this is the Ubisoft, the Ubisoft. So what we are implementing this part for Ubisoft to stake and unstake. So if you have like 5 Ubisoft, you can stake them there. But first of all, you have to connect your wallet. You will have to connect your wallet. So so weekly reward in terms of Ubi. This is the amount of Ubis you can be able to get in a week. That is 17.3%, which for banks you get 10% profit, I think, in 1 year. So which means it's really sweet, and then you can be able to convert these Ubis to sell or to CUSD. Once you are able to stake. So right now I don't have any Ubisoft. I'm just staking Celo. I'm staking Celo I'm staking Celo instead of Ubis. Yeah. So yeah. Then this the documentation and stuff, and yeah. So that's what we are building. So we are building this part. We are just implementing this part. So there are other features that maybe in the other classes we'll be able to implement, maybe like the triple reward pool and the swap. And the swap. So God willing, we'll be able to do the swap. Be able to do a swap for this. So yeah, I'm creating one for swapping. So it's still underway. I had created in the Ethereum side, but now I'm trying to put it into the Celo side, which is a little bit complicated. Yeah, a little bit. Yeah. But I'll see what I can do. Yeah. So this is the interface, the Uniswap interface. So let me get our, yeah, so then we have it. Then we can close that one and continue, yeah, from there. So, yeah. So, and then also there is a starter. There is a starter. There is a starter. So there is a just a minute. Okay. So under my repository or under my GitHub repository, there is a link. Yeah, this one. So there is a link. If you want to get started, I know there are some people who haven't been able to set up the link. If you want to get started, so download that repo and then you set it on your machine, and make sure that you have. I will resend. Let me resend the. Or somebody can try and send me the guideline for following that. Yeah. So yeah, let me say it there. So there. So follow those instructions so that you can be able to set up this repository, and then yeah. So I think now we are good to get started, and yeah. Yeah, so I think right now we can get started, and yeah, so let's get started. Yeah, so last time on Wednesday we did the yield farming. So the yield farming, we did import the two ERC20 tokens that we are going to be staking and getting rewards for. And we created the YieldFarm contract. We gave it a name farm, and we declared a variable owner, which is an address. And then we declared the token, that is the Uniswap smart contract and the Celo smart contract. And then we created an array of the staker's address and a mapping of staking balances, of all the balances, a mapping that people or a Boolean that you have staked, and of the address, whether the address has staked and whether the address is still staking. And we passed in the constructor values, that is the Uniswap, CUSD, and owner. And then we created the function for staking. We created the function for staking, and yeah. So today, so the function for staking requires you that you have an amount which is greater than 0 for you to stake, and you are staking the CUS dollar. You are staking the CUS dollar. So you are not staking the UBI. Uniswap is the one which is being given to you as the reward for staking. Then is the staking balance is updated to the mapping. So that is the address of the sender, the person who is now staking, and yeah. And this one is checking whether the person has staked. If not, you are pushed to the sender's, the staker's mapping, or the staker's array of the address. So you are added here. And then this is to check. So it changes the Boolean or the status to true, to both true. So for the unstaking, the process will be the same. So what we'll do, we'll create a function. Just a minute. We'll create a function called, so our function will be called function unstake. So our function will be called function unstake, unstake token, unstake tokens. So remember, it's a function. It should be public. And so our logic, the first thing we'll do is we have to fetch the balance. We need to fetch the balance. So you cannot be unstaking a coin if you were not pushed, or the balance, your balance is still. So we have to get the balance first of all. So we have to get the balance of the person who is unstaking. Yes. Yeah. Yes.
Hello, Joda.
Yes.
Please, can you increase your font size a bit?
Okay. Okay. Ambrose. Let me increase my zoom. Okay. I hope that one is better.
Yes.
Okay. I'll get a better screen. I'll get a better screen and a better. Yeah. Okay.
Great.
I'll get a better screen. Maybe a metaverse screen. Where you can be able to. Yeah. Anyway. Let's continue. So we'll get the balance. We'll get the balance of the person who is trying to unstake. So your balance must be in the staking balance. We have to check it from this staking balance here. This one. So it must be in this list of addresses that are there. So all the balances which are in the pool. Yeah. So that's why here we were pushing it to, we were pushing the addresses, the address together with the amount, yeah. So then balance, so balance equals staking. So staking balance. So this, we are checking the address that has connected to our application. That must be the address that we have connected here. The address that we have connected here, that we will connect here, we'll check whether the staking balance is still here. Is still the balance is in our array, so that we can be able to unstake. So there are people who would want to say that they have staked, but they haven't. So yeah. Then remember your semicolon, and then you will require that the unstaking, you cannot unstake a 0. So we'll do the same. So we are doing the reverse. We are doing like the reverse of this, yeah, of the staking token. So we are doing the reverse. So we are doing the reverse. Yeah, so we are doing the reverse of this. So we check whether the balance is greater than 0, so that our smart contract does not unstake 0. And then say that staking balance cannot be 0. So this is how you send like a message or an error message that in Solidity. So our balance cannot be 0. So you cannot unstake a balance of 0. Yeah. Then the next step, what we are doing is we are doing the transfer. So after checking and validating that that guy has a balance and they had already staked, we send them back their CUSD. So we'll transfer back the CUSD to their wallet. So we'll take back so this will be the CUSD token dot transfer. So we are not transferring from now, we are transferring. So there is a difference between transfer from and transfer. So transfer from mainly happens when a third party or another smart contract want to communicate with your smart contract. Then that's when you do the transfer from. But since we are not transferring for behalf of, we are doing a direct transfer, we will use transfer. So that will be the address. So remember, message.sender is a reserved, ms.sender is a reserved or a keyword to represent address, or like it's kind of a like self or something address. It will definitely pick the address of the person who is interacting with the smart contract. Yeah. So then there is something that I also need to share with you. There is Solidity documents, read docs. So Solidity.read the docs helps you to get the introduction of introduction to smart contract, the Solidity compiler, Solidity by example. And let me show you ms.sender. So you can be able to read like the layout, the structure, and stuff. So you can see, I was looking at yeah, so types should be under types. Yeah, so these are the types, the data types, the value types, booleans, logic operators. So the logic operators, integers in solidity. So you can leave this documentation and see why we have int and unassigned ints. So unassigned integers don't have a sign in front of them, and integers do have a sign in front of them, like minus, plus, yeah. Then we have the comparisons, the bit operators, the shift, and then addition and subtraction in solidity, division and stuff, yeah. So you can, and then this the address. So I've been using address as a data type, and it comes in two flavors. So there is address payable. So the address payable means that it can be able to receive and receive a sellers or leaver. Yeah. So this one also, it just holds a size, holds a number of like 20 bytes. Yeah, so this one does not really need to receive any if. Yeah. Then address payable means it can be able to receive and send. It can do transfer. So yeah, so you can leave this documentation, and yeah. Then we have balance and transfer. Yeah, so contract types. Then the fixed size bytes array and everything. So you can be able to read all of this and see what to use in your smart contract. Yeah. So we also have enums and stuff like that. Yeah. So there was a link that I also shared on the group that also has that. So if you visit this repository, be able to find this, not that one, this one. Yeah, be able to find this. It has tutorial 1, 2, and 3 on libraries and imports, libraries and import, inheritance, and the basics. So the basics contains the data types. This one, it contains basic, yeah. So basic, like how to set setters and getters, and yeah. So yeah. So I figured that we shouldn't really like do a lot like this, and we just get started, and yeah. So that is it on the data types and the different functions. This one is on inheritance, smart contracts inheriting other smart contracts. So like this one, this interface regulator, and then contract bank is regulator. So this is what I was saying, that this is how I was saying that you can do this as this actually inheritance, or how you can be able to do that. So there is a difference between this way, and also this regulator. Yeah, so there is a difference. And also you will be able to practice the withdraw and deposit and something and balance, or getting the balance off and checking the value. So this one is a good way to actually practice more and do more. Yeah. So yeah, you can visit also that one and you'll be good. So let's continue. So what we are doing now under line 41, we are transferring the coins back to the staker, the person who had staked. So we are returning all the coins back to them. So according to how many they have, they want to unstake. So you may want to unstake like 2 coins, and then you leave behind like 9 8 coins. Maybe you had staked 10 coins. Yeah. So, and then the balance. So this balance. So we have verified that these guys have we have verified that these guys had balance. They had balance, and this is what you are going to pass there. So the balance that they have, yeah. And then that's it. So then we need to reset the balance. So we need to reset the balance once they have unstaked. So it's very important you craft your logic very, very carefully, because if you forget like the need for resetting the balance, people will be able to there is these continuous loops, continuous, like the for loop. Solidity loops. They are continuous loops. So there are vulnerabilities. They are like there are more than 16 vulnerabilities. They're more than 16 vulnerability when it comes to smart contracts. These just are some samples of smart contract vulnerabilities. So if you don't do the balance resetting, if you don't add if you don't reset the balance, there are people who can come up with an external library, like the famous DAO attack. What they did was the hacker created another smart contract that did the looping. It did a looping. So since the balance wouldn't be able to reset, they would continuously kind of unstake their coins and continue with withdrawing more coins from the smart contracts, So yeah, that's what happened. Since the balance wouldn't be reset once the people have been able to so there is a whole story that you can be able to read. Right now I can't be able to explain more, but so these are some of the vulnerabilities. So you can go and check and then try them yourselves and see how you can counter them. And so this is the kind of the attack. So I'll share this link. So the attacks are the attacks are simple. The attacks are very simple. So if your contract is receiving ETH and you don't reset and the days, like the days of withdrawal, the refund. So this the DAO attack that I was talking about. So this is a little case example, a little world example, whereby a guy was able to withdraw. So at the time, the contract held over 150 million USD, and then there was a re-entrance. It played a major role in the attack, which ultimately led to the hard fork that created Ethereum Classic. So that's how Ethereum Classic came to be, because these guys were created a loop that would continue to siphon ethers from the DAO smart contract. And the only solution was to do a hard fork, change the entire smart contract and create a different timeline or such. Yeah. So yeah, so you have to be very careful. I always say that whenever you are creating a smart contract, remember you are dealing with people's money, so you have to be very careful unless you are a bad developer. So staking balance. So we are going to reset the staking balance, this balance. So we are going to reset this staking balance once we have transferred the coins back to the owners, to the staker. So we reset the balance. The sender. So message.sender, we have to reset the balance of that guy, and then we have to remove them from, not to remove, like reset. The data will be there that they had staked previously, but now the new transaction will be that they don't have a balance in the staking pool, in the staking pool, kind of the staking pool. And then we update the status. So remember here, we were saying that they are staking. So here we are updating the status again, saying that is staking will be false. So it will be false. So also here, remember to add your semicolon. Yeah. So yeah, that's the function for unstaking the CUSD. So yeah, lastly, let's do the issuing of Uniswap token. How do you now gain, or how do you gain tokens for after you have staken, you have staked? So how do you gain those tokens when you have been able to stake? Yes, Elvis.
Hi, Jordan. I have a question with regards to the unstaking function. Let's say let's say a particular address just unstakes an amount that is not equal to the balance. Is that possible, where you actually unstake an amount that is not equal to the balance that is at the account?
Yeah.
So if that is the case, then the staking balance, where line 43, the staking balance, you'll have automatically set the balance to 0. So if we had 400, let's say 400 coins, and I withdrew 200, that line will set the balance to 0 instead of 200.
Okay, so that's where now something like another smart contract comes in. Like that is what we call an overflow error. An overflow. It's something actually that happened to me. It's something that happened to me. So where a person, the first smart contract I created, this one, so it's called overflow and underflow attack on smart contracts. And what happens is that a lot of smart contracts did have that back in 2018. And what happened, a guy from my workplace tried to send multiple transactions. And it's something that is really bad. So this is like an explanation on how it happens. So the, like on an odometer, so the odometer goes from 0 to 999. So this is why the moment you cross over to 1000, it reverts back to the 00. So that's why we are checking the address, like the balance. If that guy really does not have the required balance, it should go back, and that's why we are resetting the balance so that the balance. Okay, there is more. There is something more you can add here. You can add more logic here. You can add more logic so that the balance should and shouldn't be like the way we did here. Like the way we did here. So in the transfer, we are saying that the balance should be greater or equals to the value they are sending. Should be equals or greater to what they have in their wallet. So here you can also add. Here you can also add that it should be greater or equals to what they had staked. So that also at the same time you don't want the person who is unstaking to also unstake for the other addresses. Yeah, for the other addresses. Like I don't know if you get, yeah, so that they don't unstake or they don't siphon from the other guys who had staked. So you are specifically checking their address. Yeah, specifically checking their address, whether it's in the pool. But you also need to read more about the overflow and underflow attacks on smart contracts so that you also you are able to do that. Yeah. So yeah, this is what happens. You can read more on overflow. And there is somebody who tried to do that, and I had to like create another smart contract. Remember, the smart contract was in the mainnet, the Ethereum mainnet, and it created a lot of concern, like a lot of issues, because the guy tried to send multiple transactions, and then there were some coins which were created out of thin air. And the only solution, like what you saw for the case of the DAO attack, they had to do a hard fork. So we also had to do like a hard fork and go back to the drawing board and create and do more research. So there is a library called SafeMath. Let me SafeMath. Open Zeppelin all. Open Zeppelin. So under Open Zeppelin, we have a lot of smart contracts. We have a lot of contracts that you can be able to use. These contracts are verified and audited, and they are audited by different organizations. Open Zeppelin itself is an auditing firm. They do smart contract auditing. So there is this math, under math, there is SafeMath. So SafeMath helps you to do to create calculation. Like let's just install it, and and then I show you how it does work. Yeah. So yeah, at Open Zeppelin. Open Zeppelin. Show if it's going to. So Open Zeppelin helps you to instead of recreating the smart contracts, instead of creating the smart contracts again, like the SafeMath and what have you, the SafeMath, reentrancy, and ownable, they just create it for you. You just install their library and then you use it. Yeah. So I just want to copy this part so that yeah, so this is the right installation. So as we wait, we can continue with this. So what we'll do, we'll be able to add this here. We'll add this here, the balance of. So we'll do the add, yeah. So what SafeMath does, SafeMath helps you to do calculation. Instead of doing them manually, they have already predefined functions to help you do the calculation. So in the overflow, like for the case of the overflow error, the error was emanating from using an old version of SafeMath, and also some people had not used SafeMath. So for like our case, we had used an old version of SafeMath. We had used an old version of SafeMath. So when we did our calculation and when people used to send their transaction, the transaction would create an arbitrary number of tokens, like tokens, a lot of tokens, and that's why you need to have to reset the balance. Once the transfer you have done a transfer, or you have done an staking, you need to reset the balance to 0 so that it doesn't like recall itself. Yeah. So hope that one is clear. Or have I confused you all?
No, thank you. It's clear now.
Okay, yeah. So there is a lot of things that really goes in, and you can leave that, so that you can leave these you can see there is also this arithmetic and over and underflow is the same as overflow and underflow error, because it occurs from the range that you have. So misusing the u int 8 to u int 256, like using different integers, yeah, it will always bring conflict. So that's why you really need to understand more. Yeah. And then there is this other one for the time lock. So there are people who are able to manipulate the time lock smart contract. Yeah. This one is when you have an ICO and you have set the time and the staking period also, and some people are able to manipulate. Yeah. Then we have preventive techniques. So the best thing to do is just use the Open Zeppelin libraries. These guys have really done a lot of work in terms of, particularly in this library, SafeMath, the SafeMath library. They have really done a lot in safeguarding the calculations and the arithmetic overflow. Yeah. So it hit like every smart contract that was created in 2018. So every smart contract that was created in 2018, if they had good developer, they were able to upgrade their smart contract. If they didn't have a good developer, the developer would attack their smart contract. Yeah. So yeah. But nothing is secure. Nothing in this world we are living in, nothing is completely secure, and that's why we continue building. That's why we continue building and upgrading. Yeah. So that's it. Is there any other question before we move on, and as we also wait for this? Yes. Hello. Is there any other question? Or you can move on. Iram, Kevin.
I'll start my laptop, but I'll get same error. Compilation failed.
Oh, okay. We'll have a session later with you. Yeah. So yeah. Then yes, Ambrose.
Another question. We can move on.
Okay. Hope you are following. Yeah.
Sure. I'm following.
Okay. So the other function that we'll be doing is now issuing the Uniswap token. Like now you have staked. So if you unstake, you won't be able to check. Yeah, you won't be able to receive Uniswap. But yeah. So this function we'll call it function issue token. So function issue tokens, and remember that our functions have to be public. And then so we require that only owner can call this function. So only the owner can perform the issuance. Like the person who can do the issuance of this token is the owner of the smart contract. But it has to be automatic. Yeah. So we require the address of the owner. So the same case here should be message ms.sender, and then it's supposed to equals owner. Then we pass in an error message. So if you are not the owner of the smart contract, you cannot be able to issue the tokens. So must be the owner of the smart contract. So must be the owner of the smart contract. Then after that, now we have been able to require that and see that the address of the person who is supposed to disperse the tokens or issue the tokens or issue the rewards to the user. Yeah. So the next step is to write the logic on how do we now distribute the tokens, and how do we know that these guys are purely the guys who are part of the staking process. So we'll create a for loop which will check whether they are stakers, whether people are stakers, and whether they are part of the staking list here. So if they are part of the staking list here, the stakers, the number of stakers. So we loop through and all the contract and see whether they are part of it. Yeah. So you can also modify it more and see, depending with the number of depending with the number of coins people have staked, you can offer them different rewards. So this is just a glimpse on a way to show you that you can be able to do it, and then you can be able to do more, so that you give rewards according to the number of coins you have staked. So for Celo wallet, the Varora wallet, that is what they do. They check the number of coins you have staked. They have even given, if you check your Varora wallet, if you check your Varora wallet, you'll be able to see that there are different options for staking. So like if you stake 5 CUSD, you'll get like a reward of, so the more you stake, the more you get coins in Varora. Yeah. And the same thing that you have seen from the same thing you have seen from Uniswap, that if you stake a number of CUSD here, see, from this contract up, yeah. So weekly reward, you can see if you stake like an amount of I don't know how many. So this is automatic. So you stake UBI to automatically participate in the governance and earn UBI reward. So for weekly, you will be earning this every week. Every week you earn this 16 UBI. So I don't know the value of UBI. I'm now tempted to do the staking also. The value of UBI. So it should be available there. Yeah, so yeah. Then once we create a for, so you just know how the for loop looks like. So we'll have a uint of I 0, and that is, and if I because so dot length which normally starts from 0. So our array starts from 0, and then we see the number of stakers who are available. Then we have the I plus increment. Then we'll get the address of all the, so from the array, we get the address of the recipient. So remember from our array here, we were pushing all the addresses here. So we were pushing all the addresses here. So what we are doing now, we are getting the address part. We are going to get the address of the recipient from the stakers. So recipient supposed to stakers from the array. Now. So we don't know how long the array is. So we are just getting all the addresses. Yeah. So this is where I was saying that you can modify so that you will be able to get the different addresses. So maybe you can do an if statement whereby you are getting if the balance is greater or equals to a specific range. So you can introduce a range of balances, like if the addresses here have a specific balance, then you do the range now. If the address are strict like 10, it will be able to receive a certain amount of coins. Yeah. But right now, they will be kind of receiving the same value. Yeah. When we ask the balance, we get the balance. So we will check the balance, whether the staking balance of the recipient. So once we have gotten the recipient address, if the address is available, then we can be able to do. So we're checking if the recipients have the balances, if if the address is available. So it could be here in the staker's address, but remember, blockchain is keeping the records are not deleted, so the address will still be in the staker's array. But to make sure that they have a valid balance, then we have to check the balance from the staking balance. Yeah. So then we now introduce the if statement here to check. So once we have identified that they have a balance, so the balance should be greater than 0. Then so this is what I was saying. Then you can create another, maybe an if else or if else statement, or if this balance is equals to 0 and it has a range, then you can be able to do transfer a specific amount of tokens. Yeah. So then here we do the UBI swap thing. We now transfer the UBI swap clone dot transfer. So we are getting the transfer, not transfer from, because yeah, getting the transfer. So it will be, remember, transfer takes in 2 parameters from what we load here. Transfer is taking two parameters, an address and a value, So we are going to send the recipient address. So this recipient address, and the value should be equals the same. They will be receiving the same amount of coins as the balance they have staked. So let's say you have staked 10 CUSD, you will get the same amount that it will be as your balance that you have staked. So you'll get 10 UBI swap. So, but you can add more logic so that people get different rewards. People are not, if you stake more coins, you shouldn't get the same reward as to a person who have staked less coins. So you can do your own logic there. Yeah. So yeah. And yeah, we have actually done, we have completed our yield farming contract. So we have completed our yield farming contract, and yeah. So the Open Zephyr smart contract has been able to install, and we can add some few things here and there. So I had asked you guys to do a bannable and a mintable and also ownable. So we're going to make some few functions here ownable. We are going to make some few functions here ownable, like approve. And approve is supposed to be done by the owner. So yeah. So and our, so let's go back to the documentation of Open Zephyr. So this is how you import Open Zephyr. Just copy this part because we don't want to do the token thing. We're going to do the ownable. First of all, we are going to do the ownable. So once you have installed the Open Zephyr at Open Zephyr contracts, it should be. So this is the latest versions which has been updated. So you can be able to see So if you normally use NPM and you use a lot of libraries, so you can be able to read the latest and the downloads. And the last day it was updated, so you can see 23 days ago. So the other one was hasn't been updated. So this is the one you need to use. Yeah. So we'll import OpenZeppelin here. Should have I think owner yeah, should have owner there. Should have owner there. So few minutes. Should be ownership, yeah. Should be ownership, and then ownable. So it should be. Should be that way. Ownership and then ownable. So yeah, that is ownable. So what we mean by ownable is that let's go to OpenZeppelin. So this smart contract, what it does, it has, you can set the owner of your smart contract. Let's say you are the developer, and only you are a group of developers, and you have ownership. So you need to make it the smart contract should have an owner. So what it does, if you go through this ownable smart contract, it has, you can be able to transfer the ownership of the smart contract. You can you can be able to set certain functions, like the one for burning and minting. If we add a function for burn and minting, the only person who can be able to mint new coin, it's supposed to be the owner, and it has to be agreed that this amount of coin I'll supposed to be minted in a certain point. Yeah. Then we have is owner. So this one is to check whether the smart contract has ownership or it's owned by anybody, if the smart contract is owned by anybody. And then here you can be able to renounce ownership of the smart contract. Then there is another function for transfer ownership of the smart contract. And then there is transfer ownership of the smart contract. So this will be the new owner. You are setting the new owner. And yeah. So yeah, transfer all the control to the new address of the owner. And so let's say maybe your address has been compromised. Somebody was able to scam you and get a private key of your wallet address. So you can be able to do that. You can transfer ownership to a new address. Yeah. So yeah, so we have this is owner, and we have only owner. So what we'll do, we only copy this and we'll just call it here. So what we'll do is we'll do the inheritance bin. So is ownable. So we have done it, that the smart contract is ownable. And then now we can be able to pass in the function. So yeah, only owner. So we are just adding that function there. So only owner. So this function can only be done by the owner. Only the owner of the smart contract can be able to do that. It's the only person who can be able to approve ownership of coins. Yeah. Approve the transfer of coins. Then here below, maybe you can add something like a function So this one, I'll leave it as your homework. So guys, do it, and then it will be really interesting for you to see what they when people are talking about governance of smart contracts and stuff like that. This is what they are like literally talking about. Like yeah. So ban from so it takes an address. It's just the opposite of transfer. It's just the opposite of transfer. So instead of addition, it is subtraction. So yeah, that reminds me something. I was supposed to add the safe math. So here we'll have ownership. Let's just go back to the contracts. And then save. And then should have safe math there. So we have also imported safe math. So we'll be able to change this value to subtraction. This one will be sub. This will be addition. And, oh, sorry. It will be multiplication. Yeah. So it should be function division. Should be first of all, we also need to say that this contract is just a few minutes. Just a few minutes. Okay, so yeah, the one for safe math is the usage is different. So it's Ambrose, you're supposed to be the one reminding me this one. So the one for
yeah.
It's supposed to be,
Yeah, using safe math.
yeah, using safe math. I'm trying to remember, but because I can see it's not supposed to be passed in here, but it's supposed to be using safe math for you in 256. Yeah. Then the I've been writing different smart contracts, so I haven't been doing ERC20 for some time. So it should be balanced. So once we have declared all, we have been able to do that using safe math for you int, then we can be able now to do something like instead of now having that text, it should be dot sub, and then the value like that. So dot sub that. And then this other one now, instead of that, it should be dot add, then the value. So the same case for transfer from this other line 44. So we should be able to do sub, so that is subtraction, but then will be safe that there won't be no overflow. We are sure that there is no overflow. Yeah. So that's it. That's how you do the add for balance too. Yeah. Did I do it? Do it right. Ambrose.
I mean,
I did my own thing here. I did my own, didn't do it right. Should be,
yeah, for the vulnerable.
even this other one, I didn't do it right. This one, it should be like this. It should be because so the function, this function is taking two parameters, yeah, A and B. So it shouldn't be like that. It should be this balance dot sub, like that. Should be like that, because it's taking two parameters, so that it's balance of the sender minus the value they want to send. And then this will be balance of the sender, the initial balance they have in their account. Whether it's 0, then we remove that equals, yeah. So it will be like that. So dot add. Yeah, it should be like that. Yeah. I knew there was something wrong because the add takes into parameters. So we need something to add to, and we need something to subtract the value from. Yeah. So the same case for this other one. So it will be balanced from and we'll have so that is dot sub and yeah. Then here we'll have balance to dot addition. Dot. The ownable, Ambrose, I'm waiting for ownable. Only owner, I'm waiting for only owner. Ambrose.
For the only owner, you just
Yeah.
have to, you imported it. You have to import it.
Yeah, I imported the ownable here. Here. The ownable is here. The ownable smart contract is here. Anyway, I think it should be okay now. It should be okay. Just a few minutes. Yeah, it should be okay. It's okay. You can either do it. You can either use it like that or just that way, or just like that. Yeah. Then the other function that I had, this one I will leave it to you guys. You have to do the research for yourselves. That is function mint and function bannable. Yeah, function mint and bannable. You'll have to check it for yourself. Yeah. Yeah, that one I won't do. So then you can reciprocate this now to the other smart contract. This one would be swap. You can do that to the same. So you can add the is ownable and also using safe math for uint. Yeah. And then now here instead of now this this function, we can have the only owner. Yeah, can have only owner there. Can have only owner there now. And this line won't be, this line now won't be required. So yeah. So it won't be required. Yeah. Then this line won't be required. So yeah. So that's it on that. Now let's deploy our smart contract now and see if we do the final details for our smart contract. So remember, once you have written your smart contract, you can do unit testing. So next week we'll do a unit testing, the final part, and then on Tuesday we do, not Tuesday but Wednesday, we do we can now get started on the front end part. Yeah. So yeah. So under deployment, we need to now add our smart contract here. So in our deployment script, we only had two deployments. We had two artifacts. We had Cerodora and Ubisoft, but we didn't have the YieldFarm because at that moment we had not completed the yield farming. So that's what we'll be doing now. We'll be completing on the, so a few minutes now. Kidogo. So under deployment script, so there are some few things that we really need to do. We had the deployer. We had the deployer here. Then we had
Network.
yeah, just a few minutes. Something. Yeah, we had network and accounts. Yeah. We had network. And then we had accounts. We had accounts. So what it means is that we have to check the network first of all. And the network won't really like play a lot, but we also need to select the accounts that we are sending to the account of the contract. So first of all, what we have done is that we have created we have deployed these two contracts. So we need to define it, or to make it more, to define it even further, so that we can be able to get the address of the smart contract that we have deployed. That is the Celo dollar and Uniswap. So what we'll do here, we'll do more. We'll do const CUSD. CUSD. Okay, and it's supposed to be await. Supposed to be await the seller dollar. So once the contract has been deployed, you're supposed to get the information of the contract. So it will be stored in this variable CUS dollar once we have deployed. So this will contain the number of tokens that have been created, the address of the contract, and the reason why we do need them is so that we can be able to set them. We can be able to set them here on this part, because they are required here. They are required here. So this data is required here by the YieldFarm. It's required by YieldFarm. So once we have deployed this contract, it will be used by the YieldFarm. So we'll do the same. This data will be required by the YieldFarm smart contract. But before that, we need to first of all import the artifact for YieldFarm. So we need to add that. So YieldFarm equals to artifact dot require YieldFarm. Yeah. So then we'll also get the data for the Uniswap. We'll do the same as const Uniswap equals to await the Uniswap dot deployed. So we are getting the data once we have deployed the smart contracts. So the moment we have been able to deploy the smart contract, we are getting that information. So now after doing that, we need to deploy the yield. We need to deploy the YieldFarm. So yeah, so we'll await deployer the same way, but will be passing different will be passing 3 parameters. So deploy. So we are passing this YieldFarm, the smart contract itself, yeah, like that. And then we are passing the data. This data will be required by the YieldFarm here, this part. So what we are doing here now, we'll be passing CUSD of the contract address that will be created once it has been deployed. And then the same case here. So we are getting the data of the smart contract, the entire data of the smart contract, and then their dot address of the smart contract. So once we have done that, we can now be able to do the same. We can declare a variable that will store the YieldFarm data, because we still need to send all the Ubisoft coins to the YieldFarm contract. So to the address of the owner. So we want to send all those coins to the address of the owner. So so we'll do YieldFarm, which is equals to await the contract that this contract this once it has been deployed. So it will get data. We get that data once it has been deployed. So we can actually console log here and so that we can be able to see the type of data that will be presented for us. So yes, data. And here we can have Ubisoft data. Yeah. So this data will actually be the JSON. It will be the JSON folders. It will be the JSON address. It will be the JSON data object. Then so dot deployed function, and then lastly we need to transfer all the tokens to the Ubisoft tokens to the YieldFarm. So we'll do await so we need to change this variable because it will bring some conflicts. So let's just name it Bitcoin. That doesn't bring us conflicts. And then dot. So remember our function dot transfer. So dot transfer. So we'll get the YieldFarm address and then transfer the coins. The dot address. And then we transfer our 1 million. So 1 million coins. This one is 1 million. So we are transferring all those coins to the address. Yeah. And then we will transfer a few all, maybe all tokens, a few tokens to the investor or something, or an address. So I'm going to send them to my wallet address. So I'm just gonna get that part. This one also, we need to also reset this one. So we need to rename it so that it doesn't bring any conflict with the, this will be US token dot transfer. So we want to transfer a little bit of the coins to our wallet for testing purposes, and then that is the address. So it should be like 10,000 US dollars. Yeah. So then we can be able to save, and then we'll be able to deploy. So what I'm doing right now, I'm doing something without having tested it. We should do testing, but I'm trusting my guts. Yeah. So after that, we'll do shuffle. Is it shuffle migrate dash network alpha coders. So it should be alpha holes. Yeah. So we should be able to, so hoping everything is correct. So let's just go through, let's see if everything is correct. So our solidity is okay. So this one does, we haven't updated that one. So this one is okay. So I hope everything there is okay. Yes. So we migrate to Alpha Holes network because we don't want to deploy something that we, first of all, yes, every network is free, whether it's local development or mainnet, it's free. Not free, but you have to pay transaction fee when you're deploying. But we are deploying to Alpha Holes because it's the test net. We don't want to deploy. We are still in the development stages. So we are not sure whether this will work, not work, but we are still developing the application before we take it to production. It's the same way you have development and production application when you're doing application development in the normal way you do. So yeah, think of Alpha Holes network as a free place to do the testing. Yeah. So yeah, it's a testing phase. Yeah. So I didn't want to take a lot of your time, so let's do the deployment, and then we end the session there, if that's okay. Yeah. So yeah, hoping that everything that we have is correct. It doesn't show any errors. So I'm thinking everything is I'm hoping everything will work because I haven't missed any semicolon, but there is always that one semicolon time itself. Praise hide and seek. So yeah. So let's give it time. So as we wait for the deployment to happen, you can ask questions. So the floor is open for questions, and yeah, as we may. So like I said, you have to be very careful because of these kind of errors, the errors that I spoke about, the overflow. So this addition and subtraction. So as you can see, normally occurs in the balance of. So this is insecure cause, but this very insecure way of writing it. Actually, it's what I'm like. Yeah, and so this is more secure. It's more secure. So is more secure. This more secure. So yeah. So you can add more logic like and balance this LV is allowed this. So what is the whole? So this one is we haven't done anything on supply chain. This one is just for swapping, like the Uniswap itself, like Ubiswap. You stake, I mean staking, it's staking or yield farming smart contract. So I figured that we start with the yield farming smart contract because that's the DeFi thing, which is like now currently going on. So the DApp is all about staking and unstaking coins. Yeah. Then later on, we'll do a USSD application. Yeah. And then yeah. So it's taking a time to bring up some. Yeah. So if you came in late, we've been doing a yield farming smart contract and a kind of Uniswap. Yeah. So I don't know. Norman, has yours deployed on Ambrose? Has yours deployed? Anyone whose smart contract has deployed? Hello. Okay. At least it's showing some. So we have a problem on Celo. 9, 5, 5 or 10, 5. Yeah. So we did want to should work now. Hello, are we still together, or am I by myself? Hello, type on the chat if you are still here. Am I by myself? Have become yeah. Vincent, are you there? Let me see. So let me first of all remove the owner.
Yeah,
Okay.
I'm here.
Okay. Okay. Hope you are following. Let me just remove the owner from only owner for now, and then. Had factored in, we had not factored in the owner part. Expected but got. Oh. Complete that one. So it should work now. It should work now if cannot imports of undefined. Let's see, deploy. See if this one is YieldFarm, yield import is the contract. Let's try again. Okay, let me just undo this completely to its original for now. Let me just undo for now. Okay, it should work. Nice. And yeah. So the network is up to date, but we so that we have like a crane installation. So every time you do like a Terraform migrate and you have added that, there is Terraform migrate dash dash reset if you want to reset the compilation so that you can kind of have a fresh installation, like a fresh update. So what I will do, since this one has created, but we don't know the address, we don't really know what happened. So you can either delete these JSON objects and then redeploy it. So obvious, you will have a different address. So that's what I would do. I'll just delete all these ABIs and then redeploy it so that we can kind of have a fresh installation. So that's the beauty of blockchain, is that you cannot, even in the testnet, you cannot go to delete like the source the way we normally do. If you have done something incorrect in your database, you just drop the database. So what you can do is you can reset, and what it does, it just deletes these JSON APIs, just deletes them, and then you have a fresh installation, like a fresh deployment, but still this address will be available on the testnet. So that's why it's good to first of all do it on the testnet, so that you can be able to do all the mistake or everything, or have it under your local development that is on Ganache. So you can use Ganache or Alpha Horus to do the testing. So you can make as much mistake as you want, and then later on you deploy it. So let me deploy it again, and we should have our smart contract now deployed. So yeah, so we are deploying 3 smart contracts, and yeah. sorry, still on mute. So yeah, we should be able to have something like this, deployment, continuation, and voila. So there. So we have our network, we have the initial migration, that is the migration.js, and then should be able to, so the deployment is going on, and so these ABIs are the ones which are going to use for our front-end application, for our front-end application. Yeah. So yeah. So apparently we cannot be able to do the console log on the deployment part. That's why it has thrown an error. So that is on me. Yeah. So, on me, yeah. So let me do it, and then yeah, so hopefully it will be a successful one. So when we do the last bit, and then we call it a day. Huh. Wow. Hello, Ambrose, are you still there? So yeah, it should work now. So this is the last bit on deployment, and it should work. Should now work. So it had some few errors. Should work. So yeah, we have been able to deploy, and we should be able to see a successful deployment. And so everything has been deployed, and so that is the final cost of the transaction. And awesome. So yeah, now we'll be set for next week to do the front end. Now, next week I'll show you how to consume the ABIs and how you can be able to do unit testing before you even do the deployment. So unit testing is something which is crucial, and we normally use Mocha and Chai, and we'll be able to do all of that. Yeah. So thank you guys for joining, and I hope next time we won't have a lot of errors like what we did have today. So sorry also for keeping you, and awesome. So bye and have a great weekend. Bye everyone, and have a lovely weekend. Bye.